everybody knows, they already shared the topic, right? Global energy challenges in lighting. Especially WLED, they mentioned, right? White LED, right? Before 1980, I'm talking up to 1980, 1990, we don't have any white LEDs. What is the cause? What is the reason?
No passports,
Sir?
There are no passports.
No?
Passports.
No? Simple question, right? Before 90, I think 90, 85, 86, I think. Okay? We have only different, okay, other colors like red, green, yellow, right? We don't have white LED. After around 1990, then we are using the white LEDs. There is a small, okay, one reason. What is that reason? I want to know. So there is a major challenge actually. We overcome in the lighting or LED research area. The major challenge is that one. What is that? Everybody knows already.
Semiconductors.
We got a Nobel Prize also in that area. In LEDs, for which invention we got the Nobel Prize? Oh, madam. Material is already exists. Okay? Invention of blue LED.
Blue LED.
Invention of blue LED. Okay? That is the major revolution in my point of view in LED industry. The major revolution is blue LED. That's why nowadays we are using white LEDs. Is it clear my point? Okay. So major challenge is, in my point of view, invention of blue LED. Even though now we are facing lot of problems with blue LED. We invented the blue LED, but there are certain problems with the blue LEDs. Okay, I will discuss one by one. Right. So before going to that, first you should understand which is called lighting. Which wavelength we can call it as a lighting? Visible is, so usually we can say IR LED. Okay? Some people say IR light. It's not light that. It's only electromagnetic wave. Light means it is visible. That is the meaning of the light, which is visible to for the human eye. That is the light. So our band is WebGR. What is the wavelength range? 400 to 700. This is the light actually. Okay, randomly we can use all waves are light. That is not correct. So light has certain band 400 to 7, which is visible to us. In WebGR also one color is not visible to us. What is that?
Indigo.
Very good. So which color we can't see? Indigo. So indigo is not a light for us. For us, I am telling what I am telling. Light is not for us. We can't see. Still we can't see the indigo directly. We can see mixing of indigo with some other colors on. Is it clear with me? Are you agree with me? Okay. So which is visible to a human eye is called light. Of course, indigo is a small part of the WebGR. We are telling that it is also light. But practically, if you say strictly, indigo is not visible to us. Will anyone see the indigo color? It's not impossible. Why? Of course. Why we are unable to see? That is my question. It is a visible region only. Still we are unable to see. What is the reason? You should have this question now. Why you are unable to see the indigo? So you have to understand our eye. Very, very important. There are a lot of physics behind the working of your eye. And one more question I want to ask you. Whether UV visible, UV IR radiations are there, right? Will it directly enter into your eye? Directly? Why? It won't enter. If it enters, what happens? It will damage your retina. Directly it will damage your retina. But your eye is not allowing to enter your UV and IR. So it is protecting in your eye. What is there? So, okay, if you go biologically, so many things are there, but that is not exactly my topic. So here, okay, so what is the importance of light? First, we will discuss. Of course, everybody knows because we are injecting the effect of light. If you switch off all these lights, what happens? You can't see. Very simple, right? We can't see. What is the that's what if you see the main application of any light is a lighting application. Lighting application is different, industrial applications are different. That's what you have to see here. Okay, worldwide lighting application is only 19%. Whatever your household, everything, wherever you are using, on the streets, how much percentage is there? Only 19%. But remaining percent we have, that is very important. Where are the other electronic consumption is? Example, your mobile, your laptops, our projection, LED screen. So like this, we have so many other applications. Lighting application means directly you can see. Directly you can use it in your domestic applications or on the street. Just for seeing the what are there in the environment. Is it clear? So the percentage is very, very small. But we should know about this 19%, especially in terms of LED. Why I am telling this 19%, we have to know about what is the effect of lighting using LEDs means. See, don't think that all LEDs are good. All LEDs are not good. I can say. At the end of this, my presentation, then you can understand what is the effect of LEDs on the human body. So many things are there. Understand? So, even though it is 19%, it will affect on the daily life of any human. How it will affect? Simple example let me tell you. Suppose if you use a normal LED, it is not a branded one. What happens? Both are giving same light output, but what difference you will feel for the longer time? See, it's not about the instant. If you use the same LED light for longer time, what will happen? Very simple. I already told you, we are using blue LED. What we are using? So blue LED is very dangerous to any human, not only human, any biological object. Any biological thing. Either if you take human, animals or any insects, this blue is not good. Further. Why? Because it is what is the energy of the blue in the picture? Is it more high energy actually? It's a high intense energy, you can say that. This high intense energy can penetrate through your skin, it can go to your retina directly, it can damage your retina also. Understand? That's why there are certain limitations. You should use certain limit of blue light in your white light LEDs. You are not supposed to use more blue light. If you use more blue light, you can feel that it's more bright. But what happens if you see more time with the blue light? It will damage your skin. It will also damage your vision. And sometimes you will feel some other effects also. Sometimes you will feel vomiting sensation, headache. Nowadays you can see even 5 years kid, 8 years kids also that I am feeling headache. Why they are feeling headache? Do you know? Why they are feeling headache now? At small age, they are not supposed to get any headache. Exactly. Because your water mobiles you are using LEDs. Understand? It is emitting continuously blue light. Their body is very sensitive to anything. And that's why not only about the addiction of mobile, it is not good for the body also. Understand? How it will affect, we will discuss. Right. So here, these are the global energy challenges we have. Now I am going with the actual problem. Okay. So what are the lighting challenges we have? Of course, every year this rising energy cost. So when we compare with the normal lights, why LED bulbs are more cost? Why it is more cost? Materials, very simple. There we are using semiconductor. We are using semiconductor, but all are costly materials. You can't get it just like that. Understand? And the other problem is recycling. Recycling of electronics is a very big headache nowadays. Whatever you are using, we are not recycling. Most of this, okay, 90% we are not recycling. Your mobiles, your screens, okay, whatever there in my hand, okay, any electronic system, like bulbs also, e-waste only. Bulb also, e-waste. Suppose I am using a bulb. What is the lifetime of a bulb? Do you know? LED bulb? Lifetime in general.
8 months. 8 months.
I want, okay, months, years. No, sir. Actual LED bulb for lifetime is 15 years. 15 years. Are you using 15 years a bulb? Why? That is manufacturing defect. If you properly design and develop an LED, we can use the same LED bulb for 15 years without any problem. That's why we are telling you better use a branded bulb. Understand? If you use a branded, at least it will come 5 or 6 years. If you use whatever roadside they are selling 100 rupees, 3 bulbs. After 3 months you have to replace. Definitely, I have seen. Practically, I have seen. Okay, I purchased one bulb and we verified how much time it will run. After 3 months, then you can see that slowly lighting is reducing. Then one day suddenly it will not work. It is not working. Because why it is not working? Then you can understand. Okay, once my meditation is coming, then you can understand. Okay. So next, of course, as the energy demands, because we are using everywhere with the bulbs, different types of bulbs for various applications, and as the population is increasing, okay, demand that means use is also increasing drastically, exponentially, not drastically. That is a major problem with population. So population is increasing exponentially, not linear. Okay, so demands also increases. Next, fossil fuels. Where we are using fossil fuels in case of LED? It's a LED, but where is this one? Fossil fuels. How it is related to this LED? Fossil fuels means petroleum products. Okay, what I am telling? See, this is also major problem with LED. Fossil fuels, that means we are using fossil fuels. For what purpose we are using in LED fabrication? So you should know what are the materials we are using. That is very important. I will show you that. Okay. Next, CO2 emission. Strictly, while using LEDs, it is not emptying any CO2. It is not emptying any CO2. 0.00001% it is not emptying. But still, I am telling that there is a CO2 emission. Where? Pre and post. Pre and post. What is pre? Fabrication. What is post? Or recycling or some other process. Is it clear? So here also it is emitting CO2. Next, of course, climate changes will affect the lighting of the LED is highly sensitive to the temperatures. Highly sensitive to the temperatures, pressures, okay, environmental effects. Okay, all these are the major challenges in the global energy lighting using LEDs. I am talking about only using LEDs. Okay, so here we will come to we'll compare with the normal bulb. Okay, right? So conventional lighting technologies and environmental effect you can see here. Incandescent bulb. The point is, I am not talking about other things. I am talking only about the efficiency. Efficiency means it will take all the parameters. Okay, its quality, lifetime, all the things will come. That's why whenever you are comparing, simply if you want to compare, we have to take the only efficiency. So what is you can see here? See, when compared other conventional lighting devices like incandescent bulb, of course, most of the incandescent bulbs we are removed. There is few places we are using, especially of course in medical applications, in laboratory applications, still we are using this. Halogen also we are using. Okay, but medical applications there is no replacement there. Because why there is no replacement means where we want high energy, we can't use LEDs. Understand my point? Where you want high intensity of energy. Understand? Well, I can't use the LED bulbs. What is the LED maximum? Usually you have seen it in your daily life. What is the maximum wattage? Maximum 12 watt. 12 watt. Okay, maximum 50 watt bulb we can use for the street light applications. Isn't it? Maximum 100. Okay. Okay. But in medical applications, some places we need 1000 kilowatt, 2000 kilowatt of energy. Is it possible with LED? It's not possible, right? So some places we can replace. Okay? So okay. Even though it is low efficiency, we should use it. So when come to the light LED, of course, why we have to use LED? Only thing is that efficiency is very high. Efficiency is very, very high. Not very high. When compared with others, I will show you the table also. Okay. So, what are the limitations are there? High energy losses. I am talking about the remaining, not about LED. Okay. So, this is a major problem actually with other bulbs and the LED lightings. So, loss of energy is very, very less. Very, very less. When compared with conventional. Don't say that there is no loss of energy. Is it clear? Loss of energy is there. Loss of energy. In every system there is loss of energy. Of course. So that energy loss may be in the form of heat or in the form of other radiations. Other radiation. If it is emitting more heat, what will happen? Usually in incandescent bulbs, take halogen bulbs, what happens? Okay, whatever the material everything will burn out, then okay, no problem, you can take another. But in case of LEDs, what happens? LED won't burn out actually. Whatever the supporting material you are taking, right, that will heat up and that will burn out. Okay, that will damage the radiation. Okay, so that's why if you see any normal LED bulb, if you remove, there is one plate. What is that plate? If you remove the bulb, there is one white plate. What is the material? White plate material. It's not plastic, sir. It's metal only. Huh? Have you removed and see the bulb? LED bulb? Anyone? If you remove that, there is a one white plate, metal plate. That is a heat absorber. Okay. So that is aluminum. It's a very low cost. It is a very good heat absorber. Okay, that's why we use a aluminum plate. Just to remove any bulb, the damaged bulb is there. Just to remove on this aluminum plate and we arrange the LEDs. Okay, right. So we have very less amount of energy loss. Of course, that's what I am telling. High energy loss means more heat it will generate. When you come to the LEDs, it will generate very less amount of heat. Okay. So this is what you can see how we evolve from 5 LEDs I am talking about. Okay, I say this. So touch. It's also manual lighting. These are not electrical. And lamp, then candles. Then we come to the lamp with kerosene. So then we come to the electrical bulbs. Okay. This is an evolution to see lighting applications. Okay, how we can use the different types of devices. Like what all our devices are. Even this is also a device. Okay, so we have different types of devices, and now we are using this LED because of high efficiency. I can say lot of challenges are there. So for our better understanding, I want to give us before going to this, because we are talking about the lighting, right? There are certain important physical parameters. What is lumen? You should know. Otherwise, it's very difficult to compare one lighting to another lighting to. Okay. What is lumen? Lumen, unit of light intensity. That's it. Okay. So very simple, I can say. What is the intensity definition? Number of photons in unit. That is lumen. Don't confuse. Okay, leave it about whatever the it's one of the unit. Okay, what is the lumen here? Number of photons per unit area. If I take here, how many photons are accommodated? Is it clear? So based on the number of photons accommodated, intensity increases. Very simple. More photons are there, more intensity. Okay. So let's come to the watt. What is wattage? Unit power, electrical energy. Okay. See, if it is taking electrical energy and it is converting to light energy. So this is output actually. This is the output power. This is the input power. So how much electrical energy we have to supply to the bulb? Okay. Then what is this one? 1 kilowatt hour. Generally we can say that is 1 unit. That is a 1 unit. This is the measurement of energy used. How much energy you are using. That we can measure in terms of this small 1 kilowatt per hour. 1 hour. 1 hour. How much wattage we have used. Is it clear? So usually taking 1 kilo as a reference. 1 kilowatt hour. So based upon the bulb, we take 5 kilowatt, 10 kilowatt, right? So now we have one more is there. Units per watt. Usually any bulb if you see, they given this parameter only. Okay? So units per watt. So for given 1 watt energy, how much of light intensity it can produce? That is the meaning of that. Is it clear? So these units are very, very important. Okay? What is lumen? What is watt? What is kilowatt? And lumens per watt. Okay? So for calculating light energy, usually what we say the energy usage. Okay? 1 kilowatt hour. So wattage into total running hours. Very simple. If I take a bulb 8 watt, then what I have to do? 8 watt into 1 hour. Okay. So like this, that means we have to multiply with 1000, of course. Okay. So then it will give the how much of energy it consumes. From this, if you know the lumen, how much lumen it is emitting for 1 kilowatt, then we can find the lumen per watt. This is the reference value for any device. So if you want to find which is best, means you have to see this value, not this value. Don't see wattage. Wattage is only it is taking. But what you are feeling that? If I take more wattage, it will give more lighting. That is not that. Even same wattage, if you observe for different companies, they are not giving same intensity of light. If you observe clearly. Understand? So which parameter we have to observe? We have to observe how much lumens per watt. If this value is more, then there is a good bulb. In terms of output. In terms of course, we have some other parameters. I will discuss one by one. Okay. Right. So, I am telling the generations now. This is the first generation bulb, gas bulb. It's already over. Next we come to the incandescent. It is also there is a gas. In the incandescent bulb also we are filling with some gas, right? Actually we should have some vacuum, but creating vacuum is difficult. So what we are filling? We are filling inert gases. Okay. Next fluorescent bulb, of course. Now we are. That's what I told you. After around 1990. Okay. After because blue LED invented around 1990. So Then after that only we are using the white LEDs. So what is the importance of blue LED? Then you can understand here. What is the importance of blue LED? Okay, these are called basic colors, right? Green, red, blue. So if you have these three colors, if you combine with different intensity lumens, I can say, with the different lumens, then you can get a required color. That is what we are doing nowadays in every LED displays. So LED, if you see, suppose your laptop is there, mobile is there, just sprinkle the water. What you have to do? Sprinkle the just drop, water on your screen. Then you can see clearly three colors at each drop. These three colors you can see. Okay. If you want to see LED, intensity variations in your screens, just sprinkle the water. Then you can understand it is not a single LED. It is a combination of three LEDs. Because that LED size is very very small, in the order of microns. Of course, nowadays we have nano also. That is what quantum LEDs. Now we are using quantum LED, right? Quantum LED is a high pixel LED. Why it is high pixel? Why it is high pixel? The LED size is in the order of nano. Understand? So if you divide in 1 centimeter by 1 centimeter into as many as number of points, that is 1 pixel size will be decided. 1 megapixel means in 1 centimeter to 1 centimeter, how many pixels are there? 1 mega. 5 mega. 100 mega means 100 mega. The points we are dividing. So as the number of points, that means pixel size is increasing, the dimension of LED drastically decreases. That defines the your quality of LED. So here, for generating the different colors, what we usually use in LED displays, either we can follow this method or we can follow another method. And the yellow, we take only yellow background. Because yellow light, generating yellow light using LED is very simple. So on that we can take the blue. So how many colors are there? That is another combination, but it cost is more. So either we can follow this method or we can follow this method, but this method you have to generate more blue light. More blue light means, because why the price of the LED is increasing means because of the materials, right? So the material used for the blue light LEDs is more cost. Understand? So that's why if you are increasing the blue light content, you are also increasing the material. The cost also increases drastically. That's why when comparing between these two, which is best? This method is best. Because here I want very little bit of blue. Understand? That's why in practical applications, wherever you can use, most of the applications we use a combination of fundamental colors RGB. That's why. So LED displays, even whatever white LED you are seeing, it is not a single LED. It is not a single. In single LED, they have taken 3 LED combinations. Understand? So that will emit different intensities of their colors. The combination of these 3 colors will give another color. That's why we are generating the white color like this. You can see here, right? The combination of these 3 colors in certain portion, we are getting a white color. So like this, we can generate all the colors. So we should remember snake. He is the father of duality. Shuji Nakamura. Sushi Nakamura. Sushi Nakamura. So Sushi Nakamura, he is the inventor of duality. He is still alive. So he is still alive. He is doing a lot of research on LEDs only. He invented this blue LED. Because of his invention only, they are able to take the see. I am showing you the combination of 3 blue LEDs. If you combine with a combination, then you can generate a different colors. That he demonstrated. For that only he got the Nobel Prize. think I mentioned somewhere, right? 2014 he got the Nobel Prize. Okay, for the invention of blue LED, not the materials. Understand? Materials already exist. Just for invention of blue LED, we got. It is not just actually. Okay, because for the invention of blue LED, it took almost 80-90 years. Continuously work, and only LED with different materials. That too, it is not intentionally invented. That point you have to keep in mind. He is working on some other material. Luckily, he found that it is everything good. See, most of the inventions are like this only. Intentionally, you can't invent anything. But we have to analyze results properly. In research, that is very important. Whatever result you got it, maybe it is good or bad, leave it alone. But if you analyze that result, definitely you will get some viewpoint. Okay? So, okay, leave it about this one. So, he invented the blue light. This is a major challenge we faced up to 1990. So, we overcome that challenge. Understand? This is one of the important challenge. Of course, whatever, intentional or unintentional, luckily we got blue LED, we are enjoying with white LED. Right? So, okay. Now come to the different types of LEDs again. So here you can see. Here you have to see the unit. Okay, I am not telling about wattage. So wattage is just companies are playing with us. All the companies are, whatever you take any company, just they are playing with us. Right? Because a layman, you will see only wattage. We don't know how much amount of energy it is converting, how much of light intensity it is giving. We don't know. We thought, okay, if you increase more wattage, you will get more light. That is not correct. Okay? So, okay. So what you have to see? We have to see the lumen per watt. So from 0.1 lumen per watt we reached up to 300 lumen per watt. So the major difference is this one only. Understand? So that indicates even for small amount of wattage. If I don't need to give, suppose if I want this much of energy of lighting, I don't need to give a 100 watt. Just I want to give 5 watt, 6 watt. That's why golden bulbs are 100 watt, 60 watt is there. Okay? It's not fluorescent, incandescent bulbs. Olden days when I was in school days, we used to use only incandescent bulbs. There are 100 watt, 60 watt bulbs only available. Okay? So nowadays we are using only 8 watt, 11 watt, 12 watt bulbs only. Okay? Of course, the main advantage is there is a very, we need only less amount of energy to blow your LED bulbs. Understand? But the point is, whenever you are selecting a LED bulb, you should be careful. In what point of view? Lumen per watt. That's why whenever we are going, whenever you go to any shop, first you see there, they will write what is the lumen per watt. This is the different companies. Then you verify, same wattage, bulbs with the lumen per watt. Then you can understand which is best. Okay? So, here, this is the main point I want to discuss. When you go to the index. So, what is this one? This is an incandescent bulb spectrum. It will emit. See, it is not emitting only visible light. You can see here why these are harmful to. Okay, in another manner, it is emitting up to 1500, 1600 nanometers. So, even though it is not required for us, just because we are using only for seeing the objects, right? For seeing the objects, what we have is required 400 to 700 only. But our incandescent bulbs is producing from 300, okay, of course, 400 to 1600, of course, still there. Okay, we have taken up to 1500 only. It is okay, one of the research work. Then we, okay, I think I have given the reference here. Okay, so if you see here, this is a bulb, LED bulb. Okay, so it is only about. If you see here, what is the wavelength here? See, what is this color? Blue. This color content should be very, very small. Don't think that we need more. If we increase, what happens? I already told it, this blue content is harmful to our body. So if you select a proper company bulb, if you go to the specifications, they will publish in their website. We have to observe the blue content. We have to observe the blue content. In some local brands, what happens? Of course, it looks like white, right? So if they have more blue content, you can see more brightness. That picture I will show you. Okay. So this is a major challenge actually. What is major challenge for us means, okay, bulb selection is very important. Otherwise it will damage your eyes, it will damage your skin, it will damage your health. Don't think that it's a very simple matter. Understand? So we have to observe the spectrum also. So here the blue content should be very small. How much is required for generating the white rays? You don't want entire spectrum. If you take other wavelengths, there is no issue for it. It is useful actually. It will activate your muscles, muscular muscles. Right? So before going to the main topic, just I want to give the difference between these three lighting technologies. It is available in the website, no problem. Directly you will get it. Just I want to discuss it here. See, this is a 60 watt. That's what I told you. Usually we use 60 watt. Now we drastically come to the less than 68 watt. That is what energy efficiency and energy cost. But the cost is very high. See, but its cost is very less. How it is very less? I can prove that LED cost is very less when compared with normal bulb. Anyone? No. Already available, sir. I purchased one bulb, LED bulb. I purchased incandescent bulb also. I can prove that when compared with the incandescent bulb, LED bulb cost is very less. Duration, very good. So we have to calculate the price of any object or any device with the how much time you are using. Usage time is very important. If I take incandescent, it will come 1 year on maximum. Automatically after 1 year you have to replace. So what is the lifetime of this one? That's what you will see here. So what is the value? $32.85 per year. You are spending. But what about this one? $320 per year. Just some calculations. Okay, don't bother about the dollar or rupees. Okay, but understand. So this cost is, when compared with other technologies, other lighting technologies, its cost is higher though. Right? So I am right. Are you agree with me? When compared with the incandescent bulb, LED bulb cost is low. Don't tell that LED cost is more. LED cost is very less when compared with the other lighting. Next, if you see environmental impacts, this is very important. Now, we don't bother about these things, but it is very important. Okay, so here, is there any mercury in the LED? There is no, but I will show you mercury is there. Okay, here we are writing no, but if you go to material, the slide is there, I will show you. We are using mercury also, but the content is negligible. Content is negligible. Okay, so next, the carbon dioxide emission. Already told you, it won't emit any CO2, but where it will emit? Pre and post. This point you have to keep it in mind. So, okay, don't think that LED will emit CO2. It won't emit any CO2. Okay, 0% CO2 emission will be there while using the LED. But fabrication or recycling, okay, during this process, it will emit a CO2. Understand? Okay. So where we can avoid? during the light fabrication. See, if you see the okay, incandescent bulb, it is made up of which material? Tungsten. That's a bulb. Inside filament, outside glass. Okay, glass is a SiO2. It is not a harmful gas. But when you come to bulb, what is the outer part? Plastic. That is a major problem. That is a major problem with the LED bulb. Why? Because plastic is harmful to us. While fabrication, it will emit some CO2. For recycling also, we are processing the plastic, right? Again, it will emit a CO2. Understand how it will emit CO2? Okay. So LED is not emitting any CO2. Whatever the materials we are using for the fabrication of that material, for recycling of that material, during the process, okay, CO2 emission is happening. And we are also using the diesel, petroleum products. But because what is this material? It's a polymer. How you can fabricate any plastic polymer from the what is the base material? Plastic base material, sir. Not rubber, plastic. It's a polymer, right? From which? What is the base material we use? Crude oil. Sir, crude oil is the main base material for the fabrication of plastic. You can mix some other materials in between. You go to fabrication of plastic, not the rubber. Rubber you can produce from the any plant. Okay? Okay. I don't want to go into details about that one. Right? So next, these are the 8 factors you have to keep in mind. So low temperatures, right? The point is, it is not sensitive to any low temperatures, but it is sensitive to high temperatures. That is a major problem in India, not in other countries. In India, see this flickering after secondary. Okay, if you see, most of the problems we are facing with LEDs, if you observe, in the summer time. During the summer time, it will become dull, it will flicker, suddenly it will be gone. Not in the winter or not in the other seasons. The summer time, why? Because there is a drastic change. Now what is the temperature? Below 30. But in the summer time, 40, 45, now we are reaching 45. So here we are using the semiconductors only, right? We already know that semiconductor material is highly dependent on temperature. So obviously, for high temperature I am talking, but not for low. If you go to low temperature, the efficiency increases. Understand? Okay. So that is the important point you have to keep it in mind. That's why for high watt LEDs, they will keep some fan also. If you go to more than more than 100 watt, okay, there is a seal, there is a metal seal observing, and also there is a nowadays we are using the fan also. Okay, especially in India. I am not talking about other countries. Other countries, most of the time they will maintain low temperatures only, below 30 or 80 degrees. But here the temperature is, those differences are there. Okay, for outside applications, not the inside any home applications, for the outside lights and the sports applications, okay, any grounds and indoor stadiums, wherever you are using, because there we need more wattage, right? So we should install along with fan. Actually, there is a very good research area. If anyone interested, you can do it. Okay, installing how to reduce the effect of temperature on the LEDs. There is a research topic. It got such very few people are working. Okay, right. So here, of course, light outputs already told you. Okay, there is no difference. Yeah. So finally, I will say these are the major challenges. What is that? High electricity consumption. It consumes very less energy, right? Then how I can say high electricity consumption? These are major challenges with other technologies. You can overcome, but not completely. Next, rising energy demand. So as the energy demands are increasing, usage also increases. Understand? These are all global challenges actually. Don't think that challenge? LED bulb is there, I am using, then where is the challenge? Okay, so that's what domestic application is 90% only, 19% only. Remaining, that's why I kept the first slide. Okay, as this remaining increases, usage of materials also increases. Okay, and other emissions, whatever I told, right? CO2 emission, usage of petroleum materials, this also increases drastically. Okay, that's what you can see. So emission of carbon. Okay, energy accessibility. So now we have to come up with some other methods to avoid these things. Whatever. Of course, one of what I am telling. So to overcome the lighting applications, LED is one of the method or one of the what you can say way of usage. But you can see we have daylight harvesting, daylight. How to use daylight? Now we are inside, right? Nowadays, if you see, there is one method using optical fiber. Using optical fiber, we can use optical fiber as a light. We don't want any bulb. Just you keep one end of the optical fiber outside. Okay? Just you take the light, capture from the sunlight, and we can illuminate wherever you want. That videos are there in the YouTube also. You can verify it. Okay? So such type of things we have to use. Okay. Next, occupied sensors. Why sensors are required? Nowadays in LEDs also, motion sensors are there. Okay. If you are there, right. So whenever the present, if any motion is there in that area, it will glow. When no motion is there, automatically it will. So we have to integrate with the sensors to save the energy. Understand? Next, especially like institutions, we should use it because we are using more number of LEDs. Understand? And sometimes what happens is this. Once class is left without switching off any light. Usually you can see like this, right? So that is the best way to we can save the energy. Understand? So we can use some sensors. Right? Next you can see what are the major challenges we can face with the LED light only. This is the major problem. What is the first one? First one is flickering. So first we should understand why it is flickering. What are the reasons? See, flickering means it is not damaged. Most of the people what they will do? If it is flickering, what happens? You replace the bulb simply. But no need of replacing any LED bulb. If it is flickering means, there is a small problem in the electronic circuitry. Most of the times, its resistance or capacitance values we have to replace. Resistance we have to replace. Okay? Very simple. If you go to any electrical person, you will remove and you will keep the same equivalent resistor value. Then the flickering. Why it is flickering means very simple. So what source we are using? What is the AC light? But what is the input required for your LED bulb? So what is there in between the circuit? Rectifier circuit. So there is a problem with the rectifier circuit. Is it clear my point? Simple. It's flickering means LED bulb is not damaged. In LED bulb, there are some components for converting AC to DC. If the circuit has some problem, then it will. That is one reason. Not all the time. Sometimes low voltage. If your board is drawing low voltage, then it will. Sometimes if you replace your bulb, this place to another place, it will work properly. Sometimes loose connection. If you are not insert your bulb properly, then also it will flicker. So flickering is the major problem in LED application. Understand? So first of all, you should understand why it is flickering. Replacing the bulb is not the actual answer for that one. So what you have to do? First you have to remove the bulb and again you insert. This is what. Then what you have to do? Whether how much voltage is board is drawing, you have to check it. Understand? So least case, just go to any electrical shop. he will verify the rectifier circuit and he will replace the whatever the component is damaged. But okay, if it is less than this 80% of CRI value, then the object looks like different colors. That is a major challenge. So we have to maintain the proper CRI value. Next, okay, this LED having different colors, how it is possible? So you have to see this color with respect to the what temperature we are maintaining. Okay, it is a warm white, cool white, daylight. That's what this is replaced. Okay, blue color, right? And observe here, looks blue color. That means blue color is more. When you go to this, okay, blue light, that's why it is a blue white. Okay, it's a blue white. It is a yellowish white. This is also white only. Yeah, white means don't think that white color. Okay, white color only. It's not about them. It's a combination of a spectrum. It has a broad spectrum. It is a white. Understand? So here the blue content is very less. Here blue content is very high. So based upon the blue content, what happens? We are moving from one type of spectrum to another spectrum. Understand? So this will decide. The spectrum will decide about the CRI. Understand? So at what temperature also very important. At what temperature you are operating your LED also will affect the illumination of light. All these are the effects on the LED light. These are the okay. We have to take the manufacturers should take care about these things before releasing the product actually. But of course, some companies don't bother about all these things. Just they will release. Okay, you take it, you face it. Understand what you can face? If I take that product, what I can face? Problems. Understand? So that's why whenever you are selecting a product, not about the LED any product, we have to think about whether we will face the problem in the future or not. In future, because whatever the effects I am telling, because of using this LED light, not about immediate effects. If you use continuously 5 years, if you use continuously 6 years, with the same light effects, then that will affect our body. Is that clear? So this is the major challenge. Next, another challenge is the reflectors and lenses. The designing of reflectors and lenses. Why lenses are required in LED? Why required LED? Lenses in LED application are LED bulbs. These lenses. Where is the lens in a bulb? You have seen the bulb, right? White LED bulb. Where is the lens? What is the lens? The outer part is there, not plastic. That is a lens. That itself is acting as a both. Okay, not a reflector. Reflector will be there back side. Okay, if you see any vehicle lights, there you can see the reflectors. Back side this type of sensor will be there. Understand? But if you see in normal bulb, then you can see outer part will be like a lens. This part, entire part and lower part will act as a lens. It will expand the light. It will expand there. That don't think that all the lenses will be we can say that converge. Okay, it will expand also. Okay. So when it will converge, when it will expand, that is based upon the input light. If it is a parallel light, it is a cylindrical light. Based on that, it will it is defined, right? Okay. I don't want to go into details about the optics. So this is very important. Diffuser. This is very important in case of LED lights. So while selecting a bulb, the diffuser will define how equal it is distributed. How equally it is distributed in the given area. If diffuser is not properly selected, then what happens? In some places you will see more intensity of light. In some places you can see less intensity of light that will affect your eye. Is it clear my point? Okay. So diffuser, that's what you can see here. Okay. Standard. If you take any standard material, the diffusion, if you see, it is a wavelength and the intensity. How much intensity of light it is allowing transmission. Okay. If you see here, certain wavelengths it is absorbing. So, some diffusers also absorb certain wavelengths. We are not supposed to select this type of diffusers. So, diffusers will act as a distributor as well as absorber. Very, very important. That's why nowadays we are using along with this diffuser, we have IR filter also inside. So it will block the air only. Don't think LED only emit visible light. It is also emitting IR. A little amount of IR. So to avoid the small amount also, we are using this material selection is very important. Okay. So if it is a very good diffuser, then you can see that from 450 to here only, it is almost a constant. That means it will allow the same intensity for all wavelengths. Understand? So this is the major problem with this diffusers means material. If you want to select this material, this value, this price is when compared to this one, it is very high. That's why local made diffusers are not properly designed. That won't diffuse the light properly in the given area. You observe it. Understand? So the diffuser plays major role because everything is ready. If your diffuser is not correct, you are not selected properly, what happens? It may absorb the light. Okay? It may diffuse in different directions with different intensities. Then what is the use of your technology? Okay. So here diffusers, optics, that's what I told you, right? Lenses and reflectors. These will play a major role in illuminating the light on the given substrate, on the given area. Okay. So all these three we can engineer. We can engineer the material. Understand? So we can vary the design, we can vary the material, thickness, we can vary the composition of materials. These are called engineering, you can say that. Okay? So we have to do some engineering. So we have to design. That's what. See, there is one software, Gmax software. Note down. Gmax software is there. That is only for understanding this optical elements like diffusers, reflectors, and lenses. So before going to establish in practically, we have to simulate these things with respect to these three parameters. What is how it is reflecting, how it is diffusing, whether it is any expanding or not. That is also very important. That's what you can say lens. Understand? So these three parameters you can analyze using that software, Gmax software. So visual industry people will do simulation, then they will manufacture. Okay? So these three are very, very important in the manufacture point of view. So this is what you can see. Three diffusers are there. Which one is best? Three are there now. Which is best? This one? This one? How we can say this is best? See, we have to see main points. One is it should be distributed equally. Okay, so we have to see here. If you see here, there is no blocks. See, if you see here, there is a place. It is not illuminating certain areas. See, these are the block areas. You can see that. Okay, so here more is there. And intensity also will compare with this to giving enough intensity. Okay, so this is some study. Okay, so like this we have to select a proper material of diffuser before using for LED application. Next, another important point you can see here. After a certain time, very important. It is diffusing properly, but for the long time, if I use 5 years, what happens? Material will go to the next. That means it will become yellowish sometimes. Okay, because it is a polymer, right? It is exposed to different temperatures, presence. Because of that, what happens? It will convert from white to another color. That also we have to study for using for the practical application. That's what you will see here. So this one, after 40 years, 10 years, sorry, you can see there is a yellowish lines here, but here there is no yellow lines. So that means this diffuser will be useful because the lifetime of LED is 15 years. So diffuser should be okay. It should be there up to 15 years. There should not be any variation in the materials. Okay. So like this is a major area we have to select the input diffuser. Of course, this is very important. This is an experimental point of view. So this diffuser, how we can analyze before going to use in practical, we have to see one point is how many LEDs we are using. That is one way. Another way, we have to, this is a diffuser, right? With the distance between the LEDs and diffuser, how the intensity is varying. Okay? All these things we have to study before going to the practical. Understand? So this is another important area we should work. And of course, lot of work they already done. Every company they will do before going to the for the business releasing the product. So this, what you understand from this picture? What you understand from this picture? Shadow. What you observe? This is a major problem with LED. You can see what you are seeing there. Anyone please explain what you observe in these two pictures? Sir, what is students? Students. What you observe? Okay, you observe this image only. What you are observing here? If you take any shadow, if you take my shadow, okay, shadow means it is blocking, we are blocking sunlight, right? Understand? But if you see any here, what you observe, there are rectangular patterns. Shadow means only it should block the light only. But why you are getting this rectangular pattern in the shadows? Or the edges of the image actually. Why you are getting? What this indicates? That indicates number of LEDs. That indicates number of because your diffuser is not good. Okay. If it is diffusing equally, then we can't see this type of images. Understand? Your diffuser is okay. Giving like if you go back, then you can understand. See. If you see here, are you seeing any variation in the intensity? Equally there, right? The intensity is distributed equally. But if you see here one intensity is there, here no intensity is there. So if you use these type of LED lights, okay, then you will get the shadows like this. So this, if I analyze this image, then I can say how many LEDs they have used. Okay, so each LED is giving one image. All are clubbing because all LEDs are not in the same place, right? One LED is here, one LED is here, another. Okay, because there is a gap between one LED and another LED. So each LED is creating one image. All these are combining, right? That is interference. What you can say that, right? So all these are interfering and giving this type of image. Okay, so this is the problem with if you are not selecting a proper diffuser. Okay, okay. So next, glare. LED glare. So I am able to see this light, right? There is no glare. Okay, glare means more intensity. Okay, more intensity in the small area is there. Then you can feel the glare. You can't see it directly. Okay, that's what you can see here. So if you see directly, if there is a glare, it looks like this. There is no glare, you can see clearly the bar. Okay, so what it will, how it is harmful to us? Because it's a more intense light, we can't see directly. Even if you see directly, it will affect your eye. Okay? Light pollution will happen. Light pollution also there, like air pollution. Like air pollution, what? Okay, we have light pollution. So this glare will produce light pollution also. Okay? So while designing your light, LED lights, you should be careful about the glare. Understand? So now next okay. So there are different types of glares. Yeah. Here you can see the difference between these two. Here more glare is there, right? Okay. There is some reflection here. And observe it. See, if you observe carefully, here there is no reflection. Here you can see the object reflection because of glare. More in this way, it will reflect the light, right? So the reflection will create some glare. There is a glare. Okay? Here nothing is there, but you feel that something is there. That's why there is some ghost. Really, most of the ghosts you observe because of glare only. Understand? If I say, yeah, there is some ghost here, right? Actually, there is no object, but I can see some object. So there is some ghost. Understand? So glare will, okay, is a major problem in a LED. So this is what brightness. That's what I told you, right? Because of the why light is decreasing. One is because of the atmosphere radiations. Okay, and one season to another season. We are moving from one season to another season. And rainy season you will see one type of light. Okay, and because of the material what they have used, this lifetime will be very less. That's what I will, because here looks like completely white. After certain time what happens? Become reddish, because whatever the material they are using for the blue, okay, it may not be that much quality. So as aging effect, it may erase, so it will become red, not a reddish, yellowish white. Yellowish to white. There is another major problem in LED lighting. Okay. So here you can see the glaring effect. Okay, clearly. See here, faint, uneven light, bright, uniform. This you have to see here. What you are able to see the different LEDs, and here this is what lumen is very important. Lumen with the meters. Okay. So if you see here, lumen with the meters, the intensity is decreasing. Okay, continuously, and here the intensity is almost constant. Okay, almost constant. So what happens here? See, entire area looks like same intensity, but here intensity is decreasing, again increasing. See, while driving it is a very difficult to drive. Looks like very simple, right? But while driving, what happens? No, you suppose if you are in a sleepy mode, definitely what happens? Accidents will happen. Because suddenly light is going down means you feel that somebody is is there in front of you. That is what illusion. Okay? There are so many things. So these things we should avoid when selecting the LED light for the street application. Okay, so very important. There is a challenge I already told, right? So major problem with the LED lights, blue light. Blue light. You have to understand the eye. You have to understand eye. See, we have violet to red, but which one is reaching up to this one? Macula? Blue. Because of its its energy. So you can say, sir, violet also has more energy, it has energy. But because of our structure, there is one layer above our eye that will reflect back the wavelength. That's why UV light won't allow our eye. If it is less content, it won't allow. That is the beauty of our eye. There is a lot of physics, engineering is there in the eye. Okay. So, but the blue is there. This blue, is easily reaching to the macula. Okay. Suppose if it reach to here, see what is happening here? There will be some damage. bulbs, okay, or you will see some okay visible problems. You can't see some colors. Okay, maybe you will see different color. It may be okay a color blindness. Okay, all these problems you will face. Okay, when you will face this, not now immediately. I can see white light now, but it won't affect now. But okay, if you use long time same bulb in your house, that will affect. If the blue light content is more than the limit, if the blue light content is more than the limit, definitely that will affect. Okay, your eye, not only eye. Okay, why I am telling not only eye means this nerve system is interconnected to your brain, right? Understand? So where your brain will be malfunctioned because of effect of this blue light. So you will feel headaches. First symptom is that one only. That is nowadays okay. All our okay, 8 years, 8 years. Also they are feeling this effect means because they are continuously they are using mobile more brightness. You see, they won't keep normal brightness. They will keep always okay more brightness. If they see continuously every day 1 hour, what happens? They are exposing to see more brightness means I am telling you more brightness means how it will become more bright, more white. Already I have put one picture, right? More blue content is there. More blue content is there. That's why in mobile they have given one mode. What is that mode? Eye comfort. Eye comfort. Some mode is there, right? Huh?
Eye protection.
Not protection. Eye comfort. There is a mode. I am not telling about the screen guard. Eye comfort or eye mode? I think eye comfort. Eye comfort mode is there. If you keep that one, you will see some reddish one. Immediately you will see because there they are reducing the blue content only. So our eye, not only eye, our muscles also, it won't accept blue light. Blue is harmful to us, like UV only. Understand? So it is not good for any human being, any living being. Understand? So this blue light is harmful to eye. Okay? So very careful about blue light. Once my elder son, he is very active. If we are seeing something, first he will question. You are seeing mobile, I will see mobile. Nowadays, my another son, he is studying first class only. What he will tell now? If I see TV, he will count time when I started. He will tell, sir, 1 hour you have seen the TV, okay, this TV, right? So I will see 1 hour, give me remote. So that's why we should be very careful about these kids. Understand? So now we are not using TV and mobiles during this time. Once they sleep, then we will do our work. Okay? Why? Because I know what is the effect of screen. Understand? So you can see our uses of TVs. Okay? So this blue light. So how to protect? How to protect from blue light? Okay, okay, if you have already specs, you have anti-reflection coating. What we have? We are using opticals, right? We have anti-reflection. What is called anti-reflection coating? Anti-reflection means what? We should not reflect. But they are coating one more layer that you don't know. There is a blue filter. There is a blue filter. It won't allow blue color. That's why if you see your specs, it's at an angle, you will see the blue color only. Reflection of your blue color, not other colors. If you see any specs, it's at an angle. Here now also I am seeing okay, blue. Okay, from my spectacles, there is a reflection of blue color, not other colors, because there is a filter that won't reflect in the same 90 degrees. Okay, it's not about normalcy. There is some inclination. That's why at certain angle you can see the blue. You have more anti-reflection coating, I think. So specs is reflecting more blue color. Okay, why they are okay, giving this blue color filter means This is the end. Okay. So another problem with our screen. Everybody using the screen, right? If I use more intensity, what happens? Like it. So now he is closing. Okay. Okay. So if you see the screen with more intensity of light, then definitely your eye will get some problem, right? So at least you take some measure by taking the filter. Blue reflectors are available in Amazon, also available. Please you take purchase, it may be $200-300. You just take that blue reflector. Then what happens? The blue color will be filtered. Reflector is not for you. Okay, it will absorb. Okay, right. So this is what you have to see. What you have to see. This is the anti-reflective coating. This is a uncoated. There is a so you can see uncoated glasses. There is a glare. You are unable to see the some parts. Okay, but don't think they are coating only anti-reflection. They are coating the filters also. You have to keep it in mind. Generally, you are using anti-reflection only because it allows more color, more intensity of light. But it is not allowing the blue color. Actually, the blue content is there. The blue content it is avoiding. Understand? So whenever, because brightness, very simple, more bright, more blue. Keep it in mind. I want to reduce the blue content. Very simple. If I reduce the blue content, automatically you can see the objects clearly. Okay? This is the spectrum without coating. So how much blue content is there? See, it is more than the other spectrums. That's what you have to see here. Understand? So we have more spectrum of other wavelengths, but it's very, when compared with blue, it is very, very small. Understand? So that's why we have to reflect the blue content, or we have to avoid the blue content, which is entering into your eye by using the anti-reflection coating. Then what happens? See here, this much intensity of blue, we are cutting it down to this much. So it is not allowing the blue color. So I can see other wavelengths. See, we are able to see something, means what is happening there? It is entering some color, that color is entering into your eye, so that we are seeing the objects. Very simple logic, right? So if I reduce the blue content, I can see the objects clearly. That is what, this anti-reflection, how it is working. This is very, who are using the mobiles, already have space, means then better you take that. This screen card also coming with I think 400, not 400, 500. It is with a blue reflector, like anti-reflection coating. If you use that one, so automatically it will filter the blue color. Some point. You don't need to bother about the intensity of light. Okay. Alright. So I don't want to go on these things. Yeah, very important. So now we told that there is a emission of CO2. I told you post and pre, but during the usage of blue LED also we are emitting the CO2. How? Whatever the electricity you are using, that is produced by using the what products we are using? For production of electricity, what product we are using? Carbon products only. That water cold. This water is good, but remaining all other methods will emit the CO2. That means the production of electricity during this, because same electricity we are using, right? So indirectly we are emitting the CO2. So to avoid these type of things, there are some smart technologies. One of the smart technologies is usage of solar panels. Along with that's what we are using. Nowadays in highways, that LED lights are glowing without any power because they have self-powered solar panels. And there are some what is this? They will glow automatically, right? There are certain type of IR sensors. LDR sensors. They are using a LDR sensor. Okay, so light dependent resistance LDR means. So whenever it comes to low intensity of light, automatically this LDR switches the bulb. Okay, so why these are very important means we are not supposed to waste the energy. We are not supposed to use the other methods and produce the CO. CO emission should reduce. So what we have, the best technology is the usage of solar panels. We have one more. Nowadays, everybody very much interested, that is hydrogen. Okay, recently, Indian Railway they introduced the hydrogen based train. Will you agree with me? Hydrogen, during the production of hydrogen, will not emit any CO2. See, we have different methods of producing the hydrogen. All are not okay. Green hydrogen. Green hydrogen only will not emit any CO2. Keep it in mind. Only green hydrogen, not other hydrogen. Okay, production techniques. We have red, green, black, green. Some other colors are there. Okay, blue, green. Red hydrogen, black hydrogen, grey hydrogen. Okay, there are different types of hydrogen production techniques. In that, only green hydrogen will not emit any CO2. Is it clear? See, green hydrogen, right, is different. Hydrogen railway, whatever they introduce, whether it is green hydrogen or not, we don't know. That is only hydrogen fuel. Okay, it is not a green hydrogen. So we should introduce green hydrogen only. Then only we can say that we are not emitting any CO2. So this is the next, maybe next 5-10 years we can see this type of technology for the usage of lights like this. We are expecting to use the H2 hydrogen on green hydrogen. I am not telling about the hydrogen. We should use green hydrogen for the lighting application. This is one of the smart method. One is solar panel. Of course, solar panel also there are some problems. Okay, this is the actual solution. Our future, we can say it is our future. Right. I don't want to do all these things. Yeah, nanotechnology. I will do 3 slides only. How this nanotechnology interlinked with the lighting applications? Because as I mentioned, if you see your screens, okay, your screen resolution you are telling, right? My screen resolution is this much. How you can say? What is the resolution of your screen? What is the resolution of your screen? Whatever you are using, 1080 HD. Okay? If it is more than that, you can see clear images. Right? So here, the LED size, already mentioned, right? LED size will define the resolution of your screen. Resolution of your screen. Here, is there any water? I will show you. See? Are you able to see different colors? Here. Huh? This is water. You have to come here. You can see. And each drop you can see different 3 colors. Okay? Because very small water also you can see. Not all waters. Okay? You can see, I can see the matrix of LED subs. Okay? After completion of my class, please you can don't throw the water. Okay? Drop it. Then you can see. Okay, that's better. Okay, but here you can see clearly because LED size is more. Okay, area is more. Okay, so here I am able to see the LED size because this is out of mm, 0.01 mm. But I want more resolution screen. Then the LED size should be in the order of nano. So my LED I have to fabricate at what size? Nano. That is possible with nano. Okay, that is possible with, so this LED size should be in the order of nano. That's why this quantum dots. Okay, yeah. So if you see here, whatever the road, okay, rods, we can say nano rods. Each rod is 1 LED. Each rod is a 1 LED. Understand? So this dimension you can see. See how much dimension is there? 500 nanometers. If we take the scale, it is around 100 nanometers. Understand? So the resolution of my screen is 100 nanometers. 100 because this rod itself is a 1 LED. Understand my point? Okay. So like this, we are using the nowadays we are using this different types of screens, right? Quantum LEDs now. I think you have to see the screen. Okay. This quantum LEDs are possible because of quantum dots. Not the quantum. Okay, nanorods. Quantum. That is little bit smaller. Dot is a 0 dimension. So there we can use quantum dots. Okay. So here you can see these are the different types of rods. Quantum. Okay. Nanorods. So each rod will emit different colors. That's what you can see here. It is emitting the different colors. So if you take 3 rods of different colors, it will give light. White there. Understand? So of course there are different types of fabrication technologies. I don't want to go into that. Okay. So we can go for the mass transfer or practically we can go for the monolithic integration. Monolithic integration technique where you can see an array of LED array, micro or nano. You go to okay, if you want more resolution, then that will be fabricated as a backplate for the applying the flow of current. Right. So this is what you can see. Major challenges. It looks like very simple. We can develop the nanorods and we can apply the voltage. I can get the a small size of LEDs. But there are a lot of challenges. From one by one, you can see major problem with the materials. We have very limited amount of materials. There are a lot of research is going on in this area. That's why, see, whatever LED TVs we are using now, screens we are using very low cost now. Okay, maybe 40,000, 50,000. But if you want high resolution, it costs around 40 lakhs, 50 lakhs. Because of the material. So there is a lot of research is going on. Next, fabrication, manufacturing techniques. Of course, we are using the laser lithography now. Okay, using the very short pulse of laser, we can illuminate and we can remove the material. Even that one also gives the only micro size, not the nano size. If you want nano size, again you have to go for the nanorods fabrication. Okay. So next, of course, what type of materials we have? This material, why you have to mix? This material produces a blue color. This cost is very, very high. And I have to combine this material with any, see, what is this one? Quantum dots. So, if you want to go for the quantum dots, I have to prepare the material as a quantum dot material. Okay. See, if you don't know about quantum material, okay, go and just go and okay. What is quantum dot? What is a nanorod? What is a nanowire? There are three, and the nanosheet also. Okay, that is about dimension actually, 1 dimensional, 2 dimensional. Okay, alright, economical means still we have a lot of work is going on to reduce the price. Okay, so the major thing is that here, assembly, because we have to assemble at nano level or micro level, it's not that much easy. In India, we don't have any fabrication technology, semiconductor fabrication technology, not only this one. So then imagine, if we want to establish in India, first of all we need a clean room. What do you require? A clean room. You should not have any small dust also. Okay? So that much of high-end equipment or that much high-end laboratory we have to establish first. Of course, government is supporting now to establish the semiconductor fabrication. Maybe in future, even that whatever the fabrication facility we are going to establish, that is not useful for this one. Again, we have to develop one more laboratory. Okay, so these are the major challenges in nanomaterials. Next, come to SEM. Why I am telling this SEM is we have global challenge. This okay. The global challenge will be taken by the SEM. Clean energy ministerial. It's a like UNESCO, like a UNESCO. What is their duty means? They have to identify the methods. They have to identify the technology which is useful for the world, where the main intention is reduce the CO2 emission. Main intention is reduce the CO2 emission, use the renewable energy. These two things are very important. So this ministerial, we are also one of the part of this SEM. Okay, you can see the India somewhere here. Right? Here. We are also one of the member of SEM. Okay, so their promise is that we have to install 1 billion, so 10 billion lights, of course 1 billion for India. 1 billion of LED lights we have to install. Okay, within 3-4 years like that they have given some target. So they initiated this program as a global challenge. Global challenge on LED lights. Just we have to replace already available other lighting technologies with the LED. That is our global challenge. Of course, in my entire world, this much they have cut for India 1 billion. Our challenge is 1 billion lights we should install. Okay? So if you install, we can reduce the energy indirectly. Because already you know how much wattage is required for the LED and the other, when compared with other lighting technologies. Okay? So here, every year they will conduct the meetings. Okay? In this meeting, 16, in the last year, they decided to install the 1 billion lights in India and overall 10 billion. Okay? Of course, there are a lot of opportunities. This is about the business point of view. There are a lot of market is there. You can see now we are at the here. Okay, it means here. So this much of business is there in the LED, because I think we have installed only 8% of lighting requirements. We have installed LED bulbs only 8%. In 100%, how much? 8%. So you can imagine 92% is their business. Still we have 92% of business is there. So here, of course, different companies are involving for funding. So this lighting market share you can see lamps and luminaries. Lamps are different, luminaries are different. Okay. So lamps we can use for the domestic applications, luminaries we can use for the industrial applications. Okay. There are a lot of other challenges. Yeah. This is a global market size of the LED. I am talking about only LED market. I am not talking about other markets. Okay. So this is the global market size up to last year. So here you can see how much is there residential. This part industrial is there. Okay, here, and a very small thing is the others. This is our business point of view. Okay, so here it has both LED bulbs, your laptops, your mobiles, all market. Okay, it is combined. Okay, okay. So you can see here our area. Okay, we have installed 42.6% of market is there among 100%. Okay. So here there is a huge, almost 50% is there, right? But combining only these 3 times. That much of market size is there regarding to a LED. So here, share of indoor lighting, you can see, this is the indoor lighting share. Now what is the status here, you can see? Okay, by this you can see, 2024, it is reduced. And we'll compare. We just take the how much it has a percentage. Okay. Next, the electricity consumption of certain end users. Okay, space cooling and space heating. Indoor lighting, you can see. Indoor lighting is very less. Space cooling is more. So like this, we are using different applications. Don't think that only for the lighting the rooms. Okay. Very important. What is this question? When I say money with LED, I already given answer. Alright? I already given the answer. So I don't want to discuss about this one. Yeah. Do light bulbs vary in quality as well as cost? Vary or not? Bulb vary in quality. If vary quality, what about the cost? Both will change, na? Quality changing and also cost also change. Don't think that 8-watt bulbs are same cost. The same cost is there. If more quality is there, same wattage, we have more cost. So variations are there. If I replace my bulb with LEDs, what should I do with the old bulbs? That is also very important. I have one old bulb, I replace with LED bulb. What I have to do with the old bulb? Recycling one. Next. Recycling. The problem with the recycling is, problem with the recycling is you don't have recycling process. If I take my bulb, where I have to submit for recycling? Just you are throwing in the dustbin. That is not the solution, right? So what I can do in my house? Do it yourself, DIY, you know, right? So we have to do some DIY. Okay? You can grow some plant, or you can develop some designing. Okay? So is blue light bad? Is blue light is bad? Bad or not? Say loud. If you want more information, scan it, you will get the more information. Okay? I want to know whether you understand or not. So, right. So, flicker-free LED, sports lighting. If you see, of course, this I don't want to discuss. Yeah. Next, another important point is recycling. I already told you, recycling is not possible in India because we don't have any recycling industry. Very, very less industry, number of industries are there. So what I can do? I forgot actually. I told you right, mercury is not there. Mercury is there. These are the materials there in every LED bulb. Mercury is there or not? But where do we mention that there is no mercury? Okay? So don't think all these materials are there. All these are materials. So if you recycle your bulb, we expect these materials, that is a very good business. But the problem is recycling, will take more cost. So we have to develop a recycling process which is we can do at low cost. Okay? Right. So here, this is what you have to do. One, recycling centers you have to find. Of course, in India, very few centers are there. Next, do your projects. You do your own projects. Okay? Then avoid improper disposal is very important. Don't throw your bulbs, not only normal bulbs, LED bulbs also, somewhere else just like that. You have to follow any one of these ones. Okay? So of course, recycling you can do. So this is what I want to show you. This is one simple video. What we can do with looks very simple, right? So like this, so many things are there. Not completed. Okay. So next, I don't want to discuss these things. What is that, madam? Just give me 10 minutes. Now I will give introduction. So my name is Kishore. I am working as a assistant professor in the Institute of Information Technology, Design and Manufacturing Department. Right? So I am working. Of course, this is my institute. These are my other faculty members working in the Department of Sciences. Physics only. Other faculty also there. These are the various research labs we have. My lab, you can see optics and photonics laboratory. Okay, one UC optics laboratory is there. We have developed there. Okay, different types of optical experiments are there. and photonics laboratory is a research laboratory. And these are the my area of work. My broad area is photonics. I am working the design of photonic crystal fiber sensors using the COMSOL and also visible and IR photo detectors we are manufacturing. That means fabrication, not manufacturing. Sorry, it's a fabrication, and we will do some studies also. And we are also working on FDCM fiber sensors and energy device fabrication. Production also we are working. These are my 4 verticals of working in the photonics. So this is my group. Currently, these scholars are working, 4 scholars are working under me. So this is my photonics laboratory. Here you can see there is a splicer, OTDR is there. This the vibration free table is there. And here very important, this is completely FBC sensor I told you, right? FBC sensing setup it is. Here we have ultraviolet and broadband spectrum source, light source is there. And using this, here actually FBC is there. Here you can't see because optical fiber dimension is 125 microns. Okay, so here there is a fiber. Here there is in the fiber there is a FBC. FBC usually used for sensing the strain, temperature, and we have one project on the FBC from the ISRO for measurement of vibration. Okay, I will show you what projects are going on. Of course, these are all equipments are there only in my photonics lab. Okay. Yeah, this setup we have developed for etching the FBC also. Okay, using HF, hydrofluoric acid, we can etch the small part of the. We are able to see the fiber, right? The fiber. So it is dimension 125 microns only. Using HF, we can etch it. A certain cladding. I think you know the what is core and cladding. So we etch the clad. So these are the setups we developed for the IV and IT measurement of for the photo detectors. Okay, these are the one of the scholars is working on the IR for the development of photo detectors using these materials. Of course, this is the fabrication method we can follow. This is the complete setup we have developed for the measurement of IV and IT. It is developed indigenously. We have not imported. This entire setup we have developed. We are going to file the idea also. And these things are we have developed in our laboratory only for the for electrical architect purpose. We have to apply the aluminum coating or gold coating on the photo detectors for the measurement of IV. That's what you can see here. After the fabrication, you can see here aluminum coating is there, right? So that we have done using this mask, face mask, arm mask. These are the measurements we got it from our equipment only. Like this, this is the complete setup for measurement of IV and IT. So here you can keep the sample. Already I have shown them here, right? Of course, this is a video. I want to see. Okay, like this we are working in one area. We fabricate different types of photo detectors and we study the IV and IT characteristics. So this is the IV detector. And we are also working on modeling using COMSOL. Anyone know about COMSOL here? COMSOL maybe one of the faculty is working in ECE. Everyone is working in the same age. So she knows very well. So by using COMSOL, we can design any, not only fibers, we can design anything, any. So this is the designing of, it's an optical fiber only, but its main advantage of photonic fiber is its flexibility in geometry. These air holes are not fixed. We can design our own design, not like a normal fiber. If you take normal fiber, we have one clad and a central one part central core is there and clad is there. That is fixed, you can't change it. But here the advantage is this geometric structure I can change. Okay, so like this we are developing different types of sensor. This is we have developed for the magnetic field sensing. Okay, like this. So these are filled with A. These are A. This is the silica, and we fill with magnetic fluid. Then we done some mathematical analysis to get the modes. How the light is guided with the different applied magnetic fields, and these modes we analyze. Then we can draw the with the applied magnetic field how this resonance peak. This we can call it as resonance peak. This resonance peak will be shown. So if we are able to find this resonance peak, I can say what is the applied magnetic field in that area. That is what. That's why this way we can say these sensors are useful for the medical application, because it can sense low field. You can see what is the field? 50 OE, 40 OE, 30, very low field. Okay, for medical application these are very useful. So that is one type of design. It is another type of design. Here, see, looks like same but not same. You see here it's elliptical, where we have taken circular. So there is a flexibility in the PCM. Okay, so I can modify some design and I can do the same type of analysis. But here we have X even, Y even. Okay, X even, Y even, X and Y R. Previous design we don't have this type of mode. We have only normal X mode and Y mode. Okay, so this is flexibility for designing. So we are working on this. We got some good results also. We are going to publish it. This is the work. Okay, she is doing. Srivani madam. She is doing the biological sensing. Okay, this is called SPR mode. Okay, surface plasma resonance mode. Using this, we can sense any biological objects present or not. I am not going to indicate about the results. If you are interested, you can contact me. And another area we are working is FBC. Already we told, right? There is a fiber. Okay, there is FBC. So this is a FBC fabrication. It is not available in our laboratory. It is available in AICTE Madras. It costs around 1.5 crore. Okay, so using that we can draw the FBCs. So like this. What is FBC means? There is optical fiber at the central core. We have to expose the light, and where is the refractive index? Okay, this small. Okay, same distance. This will act as a grating pitch. Okay, it's a grating. It has a small pitch of cap. So it's act as a grating. Already you know how grating will work. Grating will reflect a particular wavelength as per the Bragg's condition, right? The same thing we are using in the fiber. Okay, so this we can use for various applications. This is what we have seen the second for etching the fiber. This we can use for. Okay, here you can see the photograph of the etching. We also get very good results for this one. So this is after etching, you can see the variation of the actual fiber and etched fiber. It is optional microscopy based. So like this we are working in our laboratory. This is whatever we can use for the gases. So now we are working on sensing the hydrogen gas, because nowadays hydrogen is very important, right? So we want to sense the hydrogen gas, presence of hydrogen gas. So this is the experimental setup for sensing the hydrogen. Right? So these are the other areas of we are working. Already we have some results in dynamic liquid lights. So why I am very much interested in dynamic liquid lights means, like our eye, in the universe there is no object like eye, but I want to replicate it. I want to replicate means, because see, our eye you can see small distance objects, you can see long distance objects. It is not possible with any optical instrument. For every optical instrument there is some limitation. Why? Because the lenses are fixed lenses. It's not a liquid. Understand? So what I thought, okay, if I am able to develop a liquid lens, then because our eye also, how this is adjusting the focal length, there is a liquid. Okay. Yeah. So there is a liquid. Your muscles will apply some force and reduce the focal length or increase the focal length. So same principle I want to implement here. So that's why I am very much appreciate that. Only one student is working. Okay, next student. So if anyone interested, you can approach. This is my future, not now, because we don't have the application technology here. This is my future. I want to develop the FPG in PC. Okay. Of course, these are the funded projects right now. Okay. And very important, whatever the console I told you, right? If you want to purchase, it will cost more than 9 lakhs, 10 lakhs. but I got the software in iStep at free of cost. That's why I'm able to get, able to do some work in the console. So I should be very thankful to the iStep. Okay? So if you want iStep at free of cost, any faculty, not the student. So any faculty of business scholar, you can approach iStep, just log in, just approach them, request them, definitely within 1 month you will get the license. You don't need to go for any IIT software. Even if you use, you can't publish the work. It is not limited to console. We have other softwares also. Other softwares also they are providing. All these softwares they are providing. At free of cost. You don't need to pay single rupee. Okay? If you want these softwares, just register in iStep, request through iStep. Within 1 month they will give the report. Okay? So like this, I got the console multiphysics. That's why I am able to do some work in using this console. Development of different types of these doubts, any clarifications? Open to you. If you go what, then it is damaged. Yeah, that's why they are installing very high on distributing the light so that to my lab anytime you can come and visit my lab through your faculty. Don't come directly.
Thank you, sir, for giving wonderful lecture today. So all the faculty are very concentration on PPTs and images, the basic ideas of light, of LED. So these things are very valuable for our faculty. And also one thing is your established lab is very good, sir. In future we are collaborating with you, sir.
All of you to my lab.
What is that? Actually,
My topic is that one.
sir, I think that, sir,
See, everywhere